product of two vectors. Okay. When it comes to multiplication of vectors, remember there are two types of multiplication of a vector. So it's very interesting to know that vector multiplication, there are two approaches and both are giving you different results. One is a scalar multiplication, which is also called as dot product. Another one is vector multiplication, which is called as cross product. So they are symbolically represented by A dot B, which indicates scalar multiplication. And why it is called scalar, I'll tell you. And A cross B, which is called vector multiplication. So in the scalar multiplication, the product will be resulting in a scalar. That's why it's called scalar multiplication. In case of vector multiplication, the product will be resulting in a vector. That's why it's called vector multiplication. Okay, so another name for this is dot product. Another name for vector multiplication is cross product. Let's see what is it in detail. We'll start from dot product first. Okay, yes. The scalar product of two non-zero vectors, very important. Two non-zero vectors, A, vector A. Why it is non-zero? You'll understand. Vector A dot vector B is given by magnitude of vector A into magnitude of vector B into cos theta. What is that theta? Theta is the angle between the given vectors A and vector B. And obviously cos theta is also a magnitude, which is a number which ranges from -1 to +1, right? So this is a number, and magnitude of A is also magnitude, magnitude of B is also magnitude. At the end, the product remains as a magnitude only. That is why it is a scalar product. Okay, so how to find this cos theta? Cos theta can be found by taking the product divided by their magnitude as well in the reverse process. Okay, this is scalar product. So we'll see some examples and the actual operation, how to do that, I'll tell you. So right now, remember the formula. Dot product of two vectors A dot B is nothing but magnitude of the given vectors, their product into cos theta. They have to mention the angle or some other information to know this angle. Okay, so what is scalar product? We understood. The properties of scalar product is scalar product is distributive over addition. What do you mean by that? If you multiply with a scalar approach, that is A dot B plus C can be written as A dot B plus A dot C. That is distributive in nature. Okay. So similarly, if you are multiplying a lambda to anything in this order, you can multiply lambda in any order, like it is associative also in any order we can multiply. So you can multiply lambda to A and then multiply by B, or lambda to A dot B, or A dot lambda B, all are same. Okay, this is associative in nature. Okay, scalar multiplication with the dot product is associative in nature. Remember this as well. Okay, any questions so far? Any doubts? No. Okay. Let's see some example to understand the dot product of a vector clearly with the solved question itself. Okay. So before going to the questions, I can even show you how to multiply when the vector components are given. For example, if there is a vector which is represented by A1 I plus A2 J plus A3 K, and then another vector B is represented by B1 J plus B2, this is B1 J, B2, B1 I, B2 J, and B3 K. Now the product of A, B is nothing but we are going to multiply the corresponding elements. So A1 into I entire thing is multiplied by B1I plus B2J plus B3K, just for your understanding. Similarly, A2J is multiplied by all the constant part, and then A3K is also multiplied by all the parts. Now, when you multiply, what happens is, so when A1 and B1 is multiplied, fine. Okay, what is I into I? I is a unit vector, and the other one is also unit vector in the same direction, and cos theta, the theta is 0, so cos theta is 1, so it remains as a1 b1, whereas a1 b2 will be cancelled because their product is, even though we get the product, they are perpendicular to each other, cos 90 is 0. Similarly, a1 b3 is cancelled, so we will only end up with a1 b1. Similarly, we end up with a2 b2 and then a3 b3 only. That is the product of a and b. Remember this. That's because the remaining part will become 0, because any unit vector in the perpendicular direction like I cross j, I into j will become 0, I into k will become 0. The remaining part will become 0. Okay. So this is something you need to remember before solving the questions. So vector multiplication is also called as cross product. As I mentioned already, it is called cross product. What is that? Let's see. And why is it called vector product? I already mentioned why is it called vector product. So when you multiply with the vector product method, so we have to remember this right hand system where, as shown in the figure, a right-handed standard screw. Okay, there is a screw here. If you rotate the screw in this direction, the screw moves upward, right? So similarly, if you imagine your hand in as a right-handed system, indicating the thumb as a thumb pointing towards z-axis, and your x and y-axis, these remaining fingers are curved from x to y direction. So if you rotate this xy axis in the same direction, the screw moves upward in the direction of z. Okay, that's what is mentioned. As shown in the figure, in the right-handed standard screw moves in the direction of a positive z-axis when the positive x-axis is spun counterclockwise into positive y-axis. Can you see that? Counterclockwise. A clock goes like this, but we're going in the opposite direction. When you rotate from x to y, from positive x to positive y, okay, in the counterclockwise direction, the screw moves upward in the direction of z-axis, in the positive z-axis. Such a system is called right-handed system. Why are we discussing that here? When the fingers are curled in the direction away from positive x-axis towards positive y-axis, a right-handed coordinate system will be formed, and the thumb of the right hand points in the direction of the z-axis. Okay, then what we do is, here, if you want to take a cross product of the two vectors, it is modulus of A, that is magnitude of A, magnitude of B into sine theta into that n cap. That n is a unit vector which is in the direction of the screw moving upward. So as the entire product is coming as a vector at the end, it's called vector product. And remember, the angle theta is the angle between the two vectors, and we are considering the sine of this angle. Okay, and at the end, the product of A and B in the cross product method ends up as a vector because it is always associated with the unit vector n cap. Okay, that's why it's called vector product. Remember this. So, how to find the vector product of two vectors? Let's understand that with an example. Before that, some important observations here. Vector product of two vectors is also a vector. That's why it's called vector product. And it is represented by cross. If A and B are the two non-zero vectors, then A cross B is equal to 0 only if they're collinear or parallel. That is because if the theta is 0 or 180, then only, or any multiples of pi, then only it will become 0. That means if the product of the two vectors are 0, in case of dot product, what we know, product of the two vectors are 0 if they're perpendicular to each other. In case of a cross product, product of the two vectors are 0 only if they're collinear with each other. Okay. If theta is pi by 2, if theta is pi by 2, what happens to the cross product? Sine 90 will be 1. It will be vector into this. Okay. So the angle between the two vectors, angle between the vectors A and B may be given by sine theta is equal to cross product of the two vectors divided by modulus of A into modulus of B, or magnitude of A into magnitude of B. Property, another property, distributivity of vector product over addition. For example, if you are multiplying vector A with the sum of cross multiplication, right? B and C, we can multiply them by cross product like this also, A cross B plus E cross C. So this is nothing but what law? Distributive law. Right? Just like you multiply A into B plus C in a real number, we can multiply AB plus EC. That's called distributivity. Same way, if you are having a lambda with that, that is a scalar, that is also distributed just like this. Okay, so let me clear this and let's go to the examples. Okay, there's another way to get the actual value. For example, in case of dot product, if you know the components of the vector, what we do? We multiply the corresponding components. Remember? Same way, in case of a cross product, if you want to get the product of the two vectors from the component itself, we use a determinant method with the first row indicated by the unit vector, and then the second row is indicated by the components of the first vector, and third row indicated by the components of the third vector. And by finding the determinant of this matrix, we get the scalar product. That is because when you multiply same row and same column, the product will be 0 because the same direction it will be 0, whereas I into j will become minus or plus depending upon the direction. So if you follow this determinant method, you get the direct product. Okay, so that's what it is shown here. Please check this clearly. If A vector and B vectors are represented by the component form A1i plus A2j and A3k, and B1i, B2j and B3k respectively, then the cross product is given by A cross B and is represented by the determinant of this matrix. So please pay attention. It is I into A2 B3 minus A3 B2 minus j into A1 B3, correct, minus A3 B1 plus k A1 B2 minus A2 B1. So this will give you the product, the determinant of this. Okay, so remember this part. Let's go to the questions. With this, we can wind up this chapter. So this chapter is very important for our next chapter. What is it? Three-dimensional geometry, right? Yes. Yes. If there is a question here, if the given vector, if you can see the vector m and n are non-2-zero vectors, vector vector m and vector n are two non-zero vectors, then m minus n cross m plus n is equal to 2 times m cross n. This is what it's saying. So if there are non-zero vectors, what will happen is when you multiply these two vectors, m cross m, okay, minus n cross m. Yes, that is cross, right? And then minus m cross n again, plus or minus, that's going to be minus now, n cross n. So as you're multiplying the same vector in the cross multiplication, they result in 0 because they're collinear vectors, as a vector is parallel to itself, right? Now we end up with only minus 2 times n cross into m cross. Am I right? So, and when it is a cross multiplication, we just look at the product. And we know very well m cross n is equal to minus n cross m, right? Am I right? So it's a, and are they equal to each other? It is minus we are getting, but here we are getting plus. Let's see the explanation part. What do we have in the explanation part is when you are multiplying m cross m minus n cross n and m cross n into n cross n. So this is anyway 0, n cross n is 0. And we also know my m cross n is equal to minus n cross m. So these two are equal. That means we can add them and say m and n, right? So as they're equal in this thing, the answer should be A is true as well as R is also true, right? So shall we see the explanation part? Yes. Yes, explanation, both the assertion and reason is correct, and the reason is a correct explanation of assertion. That means remember now, A, if you are multiplying A cross B is equal to minus B cross A. Okay, so that is a reason we can say this, these two are equal. So as they're equal, we end up with minus and we end up with m cross n and n cross m, and we added them, right? Because they are in the here the angle in the opposite direction. That means we can reverse them. So a cross m cross n was there, and I had minus n cross m. So when you multiply, when you correct it in the same direction, it will become plus m cross n. Then we added that to 2 times m cross n. Okay, so that's why the reason is a correct explanation for a given assertion. Fine. Let's go for the next question quickly. Yes. What is it? What do we have here? If a vector A and vector B are given in such a way that magnitude of the vector A is, what is it? 2. Magnitude of the vector B is 1 by 2 root 3. And the A cross B, that is a cross product of them, is 1 by 2. And the theta is pi by 3. That's the assertion says. So we have to find the assertion reason. Is it right or not first, right? Yes. So what will you do? We're going to find the product A cross B. We are going to equate it to 1 by 2, which is equal to 2 into 2 root 3 into sine theta n cap. Okay. So what happens is 2 cancels, and sine theta is equal to what? Root 3 by 2. So root 3 by 2. So if it is root 3 by 2, what is theta? Sine inverse of root 3 by 2, which is actually 60 degree or pi by 3. Yes, that means the given reason is true as well as the assertion is true. So answer should be option A, right? Yes.